So here, we're going to assume that our triglyceride is going to be 5%, even though whole fat milk is not actually 5% triglycerides, but whatever, that's just reality. Reality has no place here. So we're required to dilute this 5% milk. By the way, forgive the costume change. Anyway, 5% milk to provide a range of known concentrations. And we're going to use simple dilution. Now, we need to decide on 3 further concentrations of triglyceride to make, and then complete table 1.1. Here is table 1.1. The difference between each concentration should be 1%. All right? We need to make 20 cubic centimeters of each concentration. So that means that our total volume will need to be 20 cubic centimeters for all of our concentrations. All of these will be 20. And that means that our volume of milk and our volume of distilled water will add together to equal 20. So this plus this will equal 20. So 20 plus 0 equals 20. That is correct. All right? So that jives with this. All right? The difference between each of our concentrations should be 1%, and we're going to make 3 further concentrations. We have 1, 2, 3 further different percentage concentrations of triglycerides in milk, and we are starting at 5% over here. Percentage concentration 5. We're starting at 5. The difference between each of our concentrations is going to be 1% each. So 5 minus 1 is 4. 4 minus 1 is 3. 3 minus 1 is 2. Now, effectively what's going on here is we have 5 parts for each of our 20 cubic centimeters. For each of our 20 cubic centimeters of total volume, we have 5 parts. So that means of our total volume of 20, 5 of those 5 parts are milk, and 0 of those 5 parts are water. In 4% milk, in 4% triglyceride, 4 of those parts are going to need to be milk, and 1 of those parts are going to need to be water. The same is true over here for 3%. 3 of those parts are going to need to be milk, and 2 of those parts are going to need to be water. And the same is true over here for 2. 2 of those parts are going to need to be milk, and 3 of those parts are going to need to be water. So 5/5 of 20 is 20. 4/5 of 20 is 16. 3/5 of 20 is 12. 2/5 of 20 is 8. Now, 20 minus 8 is 12. 3/5 of 20 is 12. 12. Same goes for here. 20 minus 12 is 8. 2/5 of 20 is 8. 12 plus 8 is 20. 1/5 of 20 is 4. 20 minus 16 is 4. 4. Now, in our answer itself, we shouldn't have all of this math over here. So all of this should have been done without this rough working. We could do our rough working off on the side over here somewhere, and we don't need all this fractional work. All that fractional work can be done in pencil, like it says, but I don't have a pencil anywhere around here, so I did it in pen. Don't do math in pen, kids. So says your math teacher. I'm not a math teacher. Anyway, now, state the concentration of triglycerides which you expect to reach the endpoint pink to white in the shortest time. Remember, we have here the triglycerides that we would expect to reach the end point, pink to white, in the shortest time. So we have, what is our enzyme reaction here? We have a fixed enzyme concentration. At no point in any of this were we asked to dilute our enzyme concentration. Our enzyme concentration E was always fixed. We were never asked to dilute E. So E is fixed. When we have fixed E and our substrate concentration is being diluted, our substrate is changing and our rate of reaction, V, is different. That is going to be the shape of our curve, which means what we expect is that substrate concentration increases, our rate of reaction will increase until we reach a Vmax endpoint sort of a deal. So that means that our substrate concentration, our highest substrate concentration, our substrate being 5% triglycerides, because remember, when we look back here, the hydrolysis of the lipase will be, the substrate for lipase will be triglycerides. 5% is our highest concentration. We expect that 5% is going to be the highest concentration. We expect that that is going to be the shortest time. Remember that as substrate concentration increases, that will be inversely proportional to our time to end point. So that means that as substrate concentration increases, end point decreases. Now, our step 1 of our reaction is to prepare the concentration of triglycerides in the table 1.1 and the containers provided. So we're going to scroll over here, and I'm going to perform this simple dilution right now. All right? Now, I have my triglycerides over here. This is what I've got. Now I have my 10 cc syringe over here. I'm going to take...
Wait, pause.